Section 6.3, Factoring Trinomials, Part 2. In this section, we focus on trinomials of the form ax squared plus bx plus c, where we cannot factor out the lead coefficient and it is not 1. Alright, so let's get straight to the method. Factoring, if we want to factor ax squared plus bx plus c, I'm going to instruct you on something called the AC/grouping method. And this works best if there are no common factors. Alright, so first, to factor the trinomial, we have to find a pair of numbers, m and n, that satisfy that their product, m times n, is the same as the AC product. So you take the coefficients a and c and you multiply them together, so the m and n must have the same product. And they must add to the b coefficient. Then what you do is you use that pair of numbers, the m and n, to break up the middle term. Use that pair of numbers to break up the middle term, and then you have 4 terms you factor by grouping. Alright, so we're going to just see a bunch of examples of this now. Alright, so factor completely 2x squared plus 3x plus 1. Now, first thing we should always check is there a common factor? So always remember that. That's your first step. Is there a common factor? So I'm going to ask that every single time. And if there isn't, I'm just going to say it, that there isn't, and we'll progress. Alright, so 2x squared plus 3x plus 1, there is no common factor. Alright, so the first thing I'm going to do is I'm going to multiply the a and the c coefficients. So 2 times 1 is 2. So I need to find a pair of numbers that multiplies to 2 and adds to 3. Pair of numbers that multiplies to 2 and adds to 3. Well, the pair of numbers that multiplies to 2, 1 and 2. So that's the only pair that works, and they also sum to 3 if they're both positive. So now what I'm going to do is I'm going to rewrite this as 2x squared, and then instead of plus 3x, I'm going to write it as plus x plus 2x. And I'm going to go ahead and write that 1 there on purpose. So plus 1x plus 2x plus 1. Now, so I've used this 1 and 2 to split up the middle term. Now I'm going to factor by grouping. 2x squared plus 1x, the greatest common factor there is x. So I'd write that as x times 2x plus 1. And then for the second grouping, there's no common factors, so I'll write plus 1 by 2x plus 1. Now there's the common binomial factor of 2x plus 1, so I can factor this as 2x plus 1 times x plus 1. And of course, as with any factoring, you can check this by multiplying it back out. 2x times x, there's the 2x squared. 2x times 1 is 2x. 1 times x is 1x. And there's your 3x. 1 times 1 is 1. Why don't you try the next one on your own? Factor completely 3x squared plus 10x plus 3. Alright, again, there's no common factor. So the first thing that I will do is multiply the a and c coefficients. 3 times 3 is 9. I need to find a pair of numbers that multiplies to 9 and adds to 10. Alright, well, let's see. The pair of numbers that multiply to 9 are 1 and 9 and 3 and 3. 1 and 9 and 3 and 3. The pair that also adds to 10 would be 1 and 9. So we want a positive 1 and a positive 9. So then I would have 3x squared plus 1x plus 9x plus 3. Now using the grouping method, 3x squared plus x, that would be x by 3x plus 1. And then plus 9x plus 3, that would be plus, be consistent here. That would be plus 3 times 3x plus 1. Again, using that grouping method. So then factoring completely, I would have 3x plus 1 by x plus 3. Two y squared minus 11y plus 12. Again, there's no common factor. So, multiplying the a and c, 2 times 12 is 24. So I need to find a pair of numbers that multiplies to 24 and adds to negative 11. Alright, factor pairs for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. I need them to multiply to a positive number and add to a negative number. That means I need I need same signs, both negative. I'm still summing the numbers. 1 plus 24 is 25, 2 plus 12 is 14, 3 and 8 is 11. So if I had a negative 3 and a negative 8, that would work. So I'd have 2y squared minus 3y minus 8y plus 12. Grouping. 2y squared minus 3y have a common factor of y, so I'd have y by 2y minus 3. And then minus 8y plus 12. Now remember, you take that sign of you take that sign of the third term, so negative, and the common factor between 8y and 12 is 4, so negative 4 by 2y minus 3. And so this factors completely as 2y minus 3 by y minus 4. And again, like with all of these, you can check your work by multiplying it back out. Alright, why don't you pause and try the next one on your own. Alright, 5x squared minus 11x plus 2. No common factor. So, let's multiply the a and c coefficients. 5 times 2 is 10. Find a pair of numbers that multiplies to 10 and adds to negative 11. And I wrote an 18 instead of a 10. Sorry about that. Alright, so let's see what we got here. Pairs of numbers that multiply to 10 are 1 and 10 and 2 and 5. So now let's see, we need them to also add to 11. Well, if they were both negatives, negative 1 and negative 10 would add to negative 11. So this would give 5x squared minus 1x minus 10x plus 2. Grouping. 5x squared minus 1x would be x by 5x minus 1. And then on the second grouping, negative 10x plus 2, that would be a negative 2 by 5x minus 1. And so this factors completely as 5x minus 1 by x minus 2. Alright, 3t squared plus 7t minus 6. Let's see. No common factor. So, using the same technique, 3 times negative 6. And be careful, keep that entire negative. 3 times negative 6 is negative 18. So I need a pair of numbers that multiplies to negative 18 and adds to positive 7. Alright, so be careful here. Since we have a negative product, I'm going to need different signs. Alright, so I have 1 and 18, or 2 and 9. Different signs, I'd take a difference. 1 and 18 have a difference of 17. 2 and 9 have a difference of 7. That's the pair that I want. Now, get the signs right. I'll take a -2 and a +9 to get a +7. So that would give me 3t squared minus 2t plus 9t minus 6. It's always a good idea at this point to check your middle terms and make sure that they have the right sign. -2 plus 9 does equal 7. Alright, factoring by grouping. 3t squared minus 2t factors as t by 3t minus 2. And then let's see, plus 9t minus 6 would factor as plus 3 by 3t minus 2. And so this would factor completely as 3t minus 2 by t plus 3. Alright, why don't you pause and try the next one on your own. Eight t squared minus 6t minus 9, no common factor. 8 by -9 is -72. So we need a pair of numbers that multiplies to -72 and also adds to -6. Alright, so let's run through some factor pairs here. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. I need them to sum to -6. Now remember, I have different signs, and so since I have different signs, I'll take a difference. 1 and 72 go to 71, 34, 21, 14, 6. I'll stop there. That's the pair that I want. 6 and 12 have a difference of 6. Now let's get the sign right. I would need a +6 and a -12 to get to +6. So that's the pair that I want. And so now let's write this as 8t squared plus 6t minus 12t minus 9. And again, now would be a good point to check. Stop for a moment, check your work, make sure that that middle term works. 6 minus 12 is -6. Alright, factoring by grouping. 8t squared plus 6t have a common factor of 2t by 4t plus 3. Factoring the second pair, -12t minus 9, I can factor out a -3 from both terms. -3 times 4t is -12t. -t times a +3 is a -9. So then this would factor completely as 4t plus 3 by 2t minus 3. Alright, so here's a couple more for you to practice. Why don't you pause and try these on your own. Alright, 40a squared plus 21a minus 12. No common factor. So let's see. 40 times -2 is -80. So I need a pair of numbers that multiplies to -80 and adds to 21. Alright, so let's see, multiplying to 80. Let's focus on that. We have 1 and 80, 2 and 40, 4 and 8. 4 and 20, 5 and 16, 8 and 10. Alright, now remember that since we have a negative product, we need different signs, and so therefore we would take a difference. 1 and 80 have a difference of 79. 2 and 40 have a difference of 38. A difference of 16. A difference of 9. I'm sorry, a difference of 11. I definitely don't know how to subtract. A difference of 11 and a difference of 2. We needed a difference of 21. None of these pairs work, so therefore this is a prime polynomial. Alright, trying the next example. 12r squared plus r minus 6. Let's see, we need a pair. There's no common factors, so let's see, 12 times negative 6 is negative 72. We need a pair of numbers that multiplies to negative 72 and adds to positive 1. Be careful there. Alright, and we just had an example with 72 as the product, so 1 is 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. And again, since we have different signs, we need a difference. And the only one that has a difference of 1 is 8 and 9. They have a difference of 1. And getting the signs right, I would need a negative 8 and a positive 9. Alright, so rewriting the polynomial, breaking up the middle term, I'd have 12r squared minus 8r plus 9r minus 6 factoring by grouping. I have 4r by 3r minus 2 and then plus 3 by 3r minus 2. And so this would factor completely as 3r minus 2 by 4r plus 3. Alright, 21b squared minus 14b minus 56. Let's factor completely. So, is there a common factor? Yes, this has a common factor. So notice that this can be written as 7 by 3b squared minus 2b minus 8. Alright, so notice that this one had a common factor, so let's factor that out first. Now, 3 by negative 8, 3 times negative 8 is negative 24. And so we want a pair of numbers that multiplies to negative 24 and also adds to negative 2. 1 and 24, 2 and 12, 4 and 6. And we need different signs, so we take a difference. So 1 and 24 have a difference of 23. 2 and 12 have a difference of 10. 4 and 6 have a difference of 2. That's the pair that we want. To make sure we get the negative 2, we would need a positive 4 and a negative 6. So we would have 7, and I'll use brackets here because I'm going to use parentheses later, 7 by 3b squared, and instead of a minus 2b, we would write plus 4b minus 6b, and then still the minus 8. Factoring by grouping on the inside. Alright, so we would still have 7 times b by 3b plus 4 minus 2 by 3b plus 4 And so then we would have 7. And let's see, we would have 3b plus 4 by b minus 2. And what we would generally do now is remove those brackets. We don't need those brackets on the outside. Alright, why don't you try this next one on your own. Factor completely 8x squared minus 8x cubed minus 16x squared plus 6x. Alright, again, notice that there's a common factor, and the common factor in this case is 2x. So I can write this as 2x by 4x squared minus 8x plus 3. So now, 4 times 3 is 12. We need a pair of numbers that multiplies to 12 and adds to negative 8. 1 and 12, 2 and 6, 3 and 4. Alright, so same signs, right? Positive 12, same signs. 1 and 12 goes to 13, 2 and 6 goes to 8. That's the pair that I want, and they would have to both be negative to get to a negative 8. So I'd have 2x, and again I'll use brackets for a moment. So I have 2x by 4x squared minus 2x minus 6x plus 3. Alright, so we have 2x by, let's see, 4x squared minus 2x, that's 2x times 2x minus 1, minus 6x plus 3, that would be minus 3 by 2x minus 1. And then writing it in its completely factored form, we would have 2x by 2x minus 1 by 2x minus 3. And again, I can remove those brackets. Oop, didn't mean to erase that. Alright, what if we had 5 minus 3x minus 2x squared? And again, we're asked to factor completely. Well, like we saw in the previous section, the first thing I would do is rewrite this in descending order as negative 2x squared minus 3x plus 5. Now I would factor out a negative 1, so negative 1 by 2x squared plus 3x minus 5. Now I will focus on the 2 and the negative 5. So 2 times negative 5 is negative 10. We need a pair of numbers that multiplies to negative 10 and adds to 3. And let's see, for 10 we have 1 and 10 and 2 and 5. Let's see, and the only one that I can get a 3 out of is the 2 and the 5. And let's see, let's get the signs right. A negative 2 and a positive 5 would get me a positive 3. So that's the pair that I want. So then this would give me negative 1, 2x squared minus 2x plus 5x minus 5. So negative 1 by let's see, we'd have 2x by x minus 1. And the common factor of 5x minus 5 would be plus 5 by x minus 1. And so we would have negative 1 by x minus 1 by 2x plus 5. And again, I'll remove those brackets. Alright, and why don't you try out this last one on your own. Alright, negative 6x squared plus 17x plus 14. First thing I'm going to do is factor out that negative 1. So let's see, I'd have negative 1 by 6x squared minus 17x minus 14. Alright, focusing on the 6 and the negative 14. Let's see, 6 by negative 14 is negative 84. So we need a pair of numbers that multiplies to negative 84 and also adds to negative 17. So let's see, 1 and 84, 2 and 42, 3 and 28, 4 and 21. I'll stop there because that's the pair that I need. 4 and 21, since they have different signs, these have a difference of 17. And let's see, we would need a positive 4 and a negative 21. So 6x squared, negative 1 times 6x squared plus 4x minus 21x minus 14. So that would give me negative 1 by, let's see, for 6x squared plus 4x, that would be 2x by 3x plus 2. And then say minus 21x minus 14, that would be minus 7 by 3x plus 2. And so we would have negative 1 by 3x plus 2 by 2x minus 7. And again, like with the others, I'll remove those brackets.